Okay, so I suppose one of the next things we might want to look at with quadratics is how they could be used in word problems. Okay, so this is always kind of an area to consider, I suppose, with any of our algebra really within maths here. So looking at quadratics in word problems, what we're really looking for here is some sort of multiplication. Okay, so there's generally always going to be some sort of multiplication of sides in a shape, for example, that would lead to a quadratic equation. Because you're kind of thinking, how can the x squareds happen? Like, what's going to cause me to have x squared? So a lot of the time that's going to come down to multiplication of different sides, maybe relative to some variable x. So we'll look at, I suppose, a few examples maybe of the sort of questions you could be asked for here. And as per, I suppose, maybe try a few of them beforehand before you just kind of follow through. But the key thing here really is just going to be converting the problem presented to us into kind of a mathematical format, taking it from kind of the word equation, I suppose. So looking at the first question that we have here, we're looking at a cuboid box. The volume of the cuboid is given to us. To find the volume of a cuboid, I suppose, because we mightn't maybe have looked at that yet, but you should maybe remember or have met before, volume of a cuboid, length by width by height, we multiply the three dimensions here. So looking at the question, length is x, width is given as 2x minus 30, and height is 10. So if I was to fill in for myself a formula here, my formula is that volume is length times width times height. If I was to fill in each of those, x is my length, 2x minus 30 is my width, and my height is 10. Multiplying those, then I would multiply those, I suppose, step by step. So start off maybe by multiplying these two here. So x times 2x minus 30, that's going to give me 2x squared minus 30x. And then I need to multiply that whole result by 10, which gives me 20x squared minus 300x. The main thing to note here from the question is that we know the volume is 5,000. So this should be equal to 5,000 because it should have been equal to 5,000 all along. So bringing, I suppose, everything together here, essentially we're subtracting the 5,000 from both sides, or bringing it across and making it negative. Very, very close to what's presented to us in the question. We're just off by a factor of 10, so we will divide across both sides by 10 there to get 2x squared minus 30x minus 500 equals 0 as required. Okay, so we've successfully shown what was presented to us in the question. And we can see what I was saying there about how we've had some sort of multiplication that has then led to squareds, and that's kind of leading us towards then the quadratic. So looking at the next part, just says solve. It doesn't tell us that it is a quadratic, so we look for, I suppose, the fact that there's an x squared, that there's an x term, that there's a constant, that there's 3 terms. All of these, I suppose, are the things that tell me it's a quadratic. We have 2 ways to solve a quadratic. We can either solve by factorizing, or we can solve by using our quadratic formula. So either of the two is absolutely acceptable here. Okay, so I suppose we can look at both ways. If I start maybe by trying by factorizing, 2x squared minus 30x minus 500 equals 0. I might look at this and think, let me try and make this a little bit simpler. So I'd look for a common factor. I can see maybe that 2 seems like it would be a common factor there. So dividing across by 2, I'm actually able to make this equation that little bit easier for myself. Okay, because I've identified the factors a little bit quicker there. So the 2 factors I'm looking for 2 numbers that would multiply to give me minus 250, but add to give me minus 15. So we're probably looking at, I suppose, plus 10 and minus 25 as my possible factors here. So we're taking this, I suppose, a little bit in the kind of longer method here. That's okay. Factoring out x minus 25, plus 10, x minus 25. So we get x plus 10, x minus 25 equals 0. So x equals minus 10 and x equals 25. Okay, looking at the 2 options here, we just have to remind ourselves what x represented. X represented the length of the box. So the length can't be negative. So that one is not possible. So therefore, x must be 25 in this case. So again, another common aspect to these questions can be, I suppose, the need to remove one of the possible solutions that you've arrived at. Okay, so that's I suppose another aspect to consider here within these questions as well. Okay, so we'll continue onwards a little bit, I suppose, and look at some of the other parts here. We'll look at maybe an exam question. So this is from the 2023 Junior Cert exam. A company is making a large rectangular poster as shown in the diagram on the right. The top section will be a square image. The bottom section will be a rectangle of height 0.5 meters, which will have the sponsor's logos. The width of the poster is X meters as shown. Write the total height of the poster in terms of X. So height of the poster, we're looking for this full length that I'm writing, that I'm kind of showing in red here. That length, I suppose, is the 0.5 plus kind of the length of that square image. So since it's a square, if this is X, then so is this side to the right here. So therefore the total height is that side X plus the 0.5 extra at the bottom there for the sponsor's logos. The total area given to us show that 2x squared plus x minus 100 equals 0. Area of a rectangle is length times width. We know, I suppose, in this one it's nearly more height and width. So let's kind of look at it that way. X plus 0.5 times x, x squared plus 0.5x. We know the area should be 50. So x squared plus 0.5x minus 50 equals 0. Very, very close again to what we have here, but not exactly. So they have 2x squared, so let's multiply by 2 to get 2x squared. 1x minus 100 equals 0. So we've got our quadratic. Part C then asks us to solve, giving our answers correct to the nearest centimetre. So suggestion there of decimals, which would tell us that we need to use the formula. So to use the formula based on what we've looked at with that one, we want to identify the letters that we would need to use. So our coefficients of our different variables here, so A, B and C, and as before we'll just list them out. So A is 2, B here is the coefficient of x, which is just a +1, and then C is my minus 100 here. So filling all of this now into my formula, it's minus b, so minus 1 plus or minus the square root of b squared, so 1 squared minus 4 times a, which is 2, times c, which is minus 100. So we'll just have a few different signs to be careful of here. All over 2 times a, which is 2. So let's keep going. So x is minus 1 plus or minus the square root of 1. And what is that going to give me? Plus 800 all over 4. So x is minus 1 plus or minus square root of 801 over 4. As usual, let's take our plus and minus aspect here now. So x is minus 1 plus 801 over 4. And that gives me an overall answer then to 1, oh sorry, my calculator's over this side. That would help. Minus 1 plus root 801 over 4. And that is 6.825, which I suppose rounded to one decimal place is just 6.8 meters. And taking the negative, I suppose, side of that then, let's look at that. We get minus 7.325, which rounded to one decimal place is minus 0.73. However, because again this represents a length in a shape, it cannot be negative, so we get that it must be the 6.8. Okay, for the width of the poster. Good. Okay, we'll maybe do one more that's just to do with forming the equation. We'll look at this one here. James is Y years old. His sister Jane is 4 years older. The product of their age is 780. Write an equation to represent this information. If Jane is Y, then Jane is 4 years older. So Jane is Y plus 4. Product means multiply. So Y times Y plus 4 should be 780. So setting up the equation here really is half the battle for these ones here. So then I'm looking for two numbers that would multiply to give me minus 780, but that would add to give me 4. So that's going to be 30 and minus 26 I've worked out here. So jumping maybe straight to our kind of simplified method for these quadratics. Y plus 30 equals 0, which means y equals minus 30. Okay, we're kind of thinking that one's probably not possible. And then y minus 26 equals 0, which means y equals 26. So in this case, we can't have a negative age, so that's going to mean that James is 26 and that Jane is 30, because she's 4 years old. Okay, so I suppose the key thing here, as we've said with most word problem ones really, it's about just forming the equation. Once we form the equation, it's using your normal quadratic methods to solve said equation then.